Hello, hi. My name is Amirul Haizat bin Azmi.
My name is Wanur Ainauni binti Marizaki.
Hi, my name is Kamisah binti Yahya.
Hello, my name is Muhammad Faiz Shazani bin Muhammad Fadzil.
Introduction to the topic we selected. Topic 4. Relation and function as directed graph. When we use the navigation app, we are always interested in seeing how to get from one location to another through the route shown on the map. The ordered pair is a set of input and output that representing a relationship between two values. A relation is a series of input and output, while a function is a one-output relationship for each input.
Graph-directed graph trees and binary trees exist in many fields of mathematics and computer science. Directed graphs are also useful in a number of dynamic systems such as digital computers or flow systems. This chapter sets out the basic meanings and properties of the goal.
The logic is the core of the reasoning. We use logic in our daily life. We will decide whether the argument is true or false. We use logical control system rules to determine how they should work. For example, in a trolley, the logical rule can be set as if the weight that the trolley can support is only 50 kg, so we should avoid putting goods in excess of 50 kg. Apart from that, we are also using logic to deduct the conclusion of the statement. In this chapter, we are going to look at the basic in the algebra of proposals.
The objective of this video is to understand the relation and function of directed graph, basic connection, truth table, and logical equivalence, and also to describe the procedure to solve problem statement from past year question. For the problem statement from past year question, we choose to share the solution of October 2010 question 4b, October 2016 question 4a, October 2007 question 5a, and October 2008 question 5a.
Firstly, we need to identify the relation of A and list down all the elements of A multiple A. Then find the elements of R by x minus y more than 5 and list down all the elements of R. This is to make it easier for you to answer the question. For the first question, to draw the directed graph, we need to draw all the vertex of R, which is 2, 8, 14 and 18, then connect one vertex to its partner. We have to connect the vertex with an arc, 8 to 2, 14 to 2, 14 to 8, 18 to 2 and 18 to 8. For the second question, firstly we need to identify the properties of the directed graph and make sure all the properties is applied in every vertex. Our directed graph is not reflexive because there is no loop at every vertex. Not symmetry because 8 to 2 elements of R, but 2 to 8 not elements of R. Also not antisymmetry because don't have most an arc between two vertices. Not transitive because there is an arc from 8 to 2 and 18 to 8, but there is not an arc from 2 to 18. So, R is not equivalence relation.
Do you have a problem to answer this question? Don't worry, let me help you. First, you need to read the question and try to understand what they want. So, regarding the question, we can say it want us to state the domain and range. Let's see the graph of relation R and list down all the elements. For example, that we have, which is AB, AD, CC, CT. Okay, look for the AB. The right side is codomain and the left side is domain. But we can't easily assume it was the answer because we need to draw the diagram of domain and codomain like this. After you draw the diagram, you need to connect all the domain and codomain. The important thing you need to memorize is only one domain can have one codomain and one codomain can have many domain. So only domain D have one codomain, which is E. So this final answer is domain is D and range is E. Next, move to the next question, which is to identify whether it is antisymmetric or not. Antisymmetric has at most an arc between two vertices. Okay, let's come with me. 1, 2, 3, 4. So there's more than one. So the final answer is not antisymmetric because the arc between two vertices is more than one. Thank you for watching.
For today, I choose question part A from past year October 2007. Okay, as you can see here, I already insert a true-false statement in the P, Q and R. Okay, let's start from here. P and Q. P is Q. Okay. You must read the P first and then Q. So P and Q. Alright. So when true, it will be true. True. And true, false will be false. True, false again will be false. False, true will be true. False, true will be true. False, false will be true. And false, false will be true. Okay, next we will move to RQ. So again we will start from R and to Q. Okay, so true here will be true. False, true will be true. True, false will be false. False, false will be true. True, will be true. False, true will be true. True, false will be false. And then last, false, false will be true. Okay, and from this one, and this symbol means and. So again we will start from here to here. Okay, so here to here. Okay, true will, so and will be true. True and true will be true. False will be false. False, true will be false. And true will be true. True will be true. True, false will be false because it's and right. So the last one is true will be true. So let's continue to the next logical equivalence. As you can see here, P or R and in bracket P or R first bracket if statement Q. Okay. Now we need to identify if the previous equivalent is equal logically to the in bracket P or R close bracket if statement Q. So let's start with P or R. This symbol mean or. Okay, so true or true, so will be true. True or false will be true. True or true will be true. True, false will be true. False, true will be true. False, false will be false. False, true will be true. And false, false will be false. Okay, the last one is there. Okay, so now we will identify whether the previous equivalent is logically equivalent to the current one that we do right now. Okay, so same one, we will read from here to Q. Alright, so let's start from here. True will be true. True again will be true. True, false will be false. and true false will be false, true will be true, true false will be true, true false will be false, and last one false will be true. So as you can see, the pattern over here and here is logically equivalent to each other. So the conclusion is the previous equivalence is logically equivalent to the new one.
First of all, if you see the negation outside the bracket, we need to expand it, so we're supposed to use De Morgan's law. After that, you need to change the implementation using implication law. When the expression have negation, so we need to use double negation law to solve the expression, and it will become like this. And the last one, we need to use absorption law.